Hi everyone, I'm Amjad and I will be presenting my PhD proposal, which is about using Mirage unikernels to develop self-managed services. So the focus of my research will be on addressing the autoscaling problem of large-scale distributed cloud microservices. Generic autoscalers found in cloud platforms require extensive profiling to get the scaling thresholds right and are only suitable for single-tier services. Most autoscalers end up either over or under provisioning resources. Um, Predictive models can be used to estimate the required amount of resources in advance based on forecasted workload. However, it's challenging to maintain these models as your software evolves. So building good autoscalers where you have the just right amount of resources under a varying demand while meeting your service level objectives requires expensive specialization for every new system. So I'm proposing to leverage the fast startup times of unikernels to replace predictive models with fine-grained, just-in-time resource allocations, and to combine that with distributed tracing to build zero-touch autoscalers for microservices. And this unique combination would allow us to address the core dimensions of scaling, where, when, and how much resources should be allocated at any time. So here we can see the trace corresponding to a single request with multiple spans, each representing the time spent at each service. The span of the front-end service represents the end-to-end response time, and distributed tracing would allow us to identify the root cause of a response delay by locating the largest resource waiting time in the request path. We would then, through timely and fine-grained resource increments, resolve this additional waiting time in order to meet our service level objectives. So in the context of just-in-time resource allocation, it is important to note that it's not only about VM or container startup time. So here we can see the overall overhead of a single function invocation in a serverless platform. As we can see, in addition to the container startup time, there is a non-negligible overhead for centralized scheduling and service discovery. So I'm proposing to eliminate all these overheads by restructuring the entire autoscaling infrastructure from the ground up. Here we can see the infrastructure support for inter-service communication in the service mesh architecture based on STO and Kubernetes. So in addition to embedding the sidecar proxies into their corresponding services, which represents an important overhead for any single inter-service invocation, I propose to replace the centralized service discovery with decentralized bottom-up resource scheduling, which would make client-side load balancers discover new resources much more faster and thus become much more responsive to unexpected workload bursts. And this is what I mean by self-scaling architecture, which is attractive to build within kernels. And this decentralized low overhead design is extremely relevant if we go beyond a single data center, especially in the context of 5G services. So in summary, my goal is to build zero-touch autoscalers where reactive policies are sufficient to achieve optimal elasticity, and I will try to achieve that by monitoring resource waiting time and reactively resolving them just in time. I want to explore the potential of this approach to improve existing systems based on containers and other lightweight virtualization options, but I also plan to go beyond their limits through unikernels. So, so far, I believe the most relevant work happening now in the literature is around serverless, where functions can be invoked instantaneously in response to an unexpected demand. However, VMs are much more cheaper, and VM and serverless can be used together to improve the effectiveness of predictive policies, which exactly demonstrates what I want to achieve in a much more effective way. With that, I'll be happy to answer any questions, and thanks for your attention.